right, we are back with our first video for 2.3. Okay, today we're going to be discussing symmetry tests. All right, so our learning targets for today to write VR data interval increasing and decreasing. We're going to apply tests for symmetries. Okay, in this first video. Yes, ready? Here we go. So there's two types of functions, okay, and this is how we're going to test for symmetry. First type of function that we're going to discuss are the even functions. All right, a function that is even is a function that is symmetric to the y-axis, meaning like an even function would be an example would be a squared. X squared is symmetric about the y-axis. If you look on the y-axis, there's my y-axis, right? Okay. This would be, wow, that would be symmetric, meaning I can flip my function over that y-axis. All right, I can fold it in half and it'll be the same. Okay, same thing if I were to have the absolute value function. The absolute value is the v. If I have the function, it is symmetric to the y-axis as well. Okay. An odd function would be symmetric about the origin. Okay. Oh, an even function, if I plug in f of negative x, I should get out my original. All right, and we'll discuss that in the coming slides. Okay. An odd function is symmetric about the origin. And symmetric about the origin means, now I want you to leave some space here. Okay, so don't write these pictures down here because we're going to come back to it later. All right, symmetric about the origin is something like a cubic. Okay. A cubic goes through our origin. Right here. Remember, the origin is this point 0, 0. That would be symmetric about the origin. All right. Same thing with a linear function. Linear functions go through the origin. They're considered to be symmetric. Odd functions. Okay. And that's saying if I plug in negative x, I'll get the opposite of my original value. I'll get my opposite of my original value. So what does this look like graphically? Okay. Well, if I have my parabola, let's draw on a parabola here. All right, there's my parabola. Okay, this is going to bother me. There we go. All right, so if I have my parabola here, okay, whatever this x value is, this is some x value here. Let's say it's 2. Okay, so let's say there is the point. Well, if I make my x value negative, so if I make that become negative 2, will I have the same y value? Will I have my original? So if I plug in 2, and then let's just say my function is x squared, I'll get 4. Well, if I plug in negative 2, I will get the exact same exact same output. So if I plug a negative or a positive number in, it will have the same exact output. No matter where you are on this function, if I started here, whatever x value that is, the y value will be the same if that number is negative as well. Okay, so that's what that means if it's even. If I plug in a positive or negative x value, I'll have the same y value of that number. Okay. Symmetric about the origin, this is symmetric to the y-axis. So if we're talking about odd functions mean if I plug in negative x, all right, I get the opposite. Oppo. So if here's my function, the cubic, the disco man, all right, so if I plug in some positive x, and I get this value. If I plug in that x and make it negative, that same x value, I will get the opposite of this value here. So let's say my x value was 3. Well, 3 cubed is 27. Well, if I plug in negative 3 to the third power is negative 27. So these values, these outputs, are the opposite of each other. So that's how you know it is odd, an odd function. Okay? So let's do a test. Is this function even, odd, or neither? All right, so in order for a function to be even, right, in order for a function to be even, okay, for even, f of negative x must give me my original. And for odd, f of negative x must give me the opposite of my original. Okay, so I want to do two things first. All right, I want to do two things when testing. I want to find f of negative x, and then I want to find the opposite of f of x. So I want to find here f of negative x because I already know what f of x here. I was given f of x, or in this case, g of x is x cubed minus 1. So I want to find what g of negative x is. Well, based on our previous, previous studies or previous units, I know that I'm going to plug negative x in for x, cube it, and subtract 1, and I'll get negative x cubed minus 1. I also want to find, let's make this a different color, the opposite of g of x. Well, my original function was x cubed minus 1, so I'll just put a negative out in front of it, negative x cubed minus 1, which will give me negative x cubed, distribute the negative, plus 1. So first thing, we can just figure out, are these two the same? When I plugged in negative x, did I get back my original function? The answer was no, so it's not even. Not even. Okay? When I plugged in negative x, was that the same as the opposite of x? No, so it's not odd. Whoa. Not the same. So this one would actually be neither. That would be a neither. That would be a neither. Because g of negative x doesn't give me the opposite of f of g of x. And g of negative x does not give me g of x back original. So it's not even, and it's not odd, so it's neither. Alright, so let's try another one. So remember from our rational exponent days, all right, x to the 4/3 is the same thing as the cube root of x to the 4th. So this is the cube root of x to the 4th. Remember, the denominator is your index, all right, and the numerator is the exponent. Okay, so what I'm doing is I'm going to take f. I'm going to find f of negative x first, which would be 6 times the cube root of negative x to the 4th minus 5, which equals 6 cube root. Well, if I raise anything to an even power, it just becomes positive of x to the 4th minus 5. Okay, I also want to find the opposite of f of x, which is the opposite of 6 cube root x to the 4th minus 5. Okay, which becomes negative 6 cube root x to the 4th distribute your negative plus 5. Okay, so if I look here, when I plugged in negative x, did I get my original? Well, are these two the same thing? Yes, they are. So that tells me this function is even. Now, for the sake of math, all right, we're just going to look down here. If I plugged in negative x, are these two the same? Right? Is this the same as that? No. All right. So usually, I mean, when a function is even, it's not going to be odd. Okay. But I'm just going to show you for the sake of fun, and because I heart math. All right. I'm just going to compare those two. So this function is actually even. Okay. Those are our symmetry tests. That was fun, quick, and painless. Hope you enjoyed it. See you next time.